Hi everyone, welcome to my another lecture on discrete mathematics. In this lecture, the learner will be able to understand how to find DNF and CNF, disjunctive normal form and conjunctive normal form without using table, truth table, without using truth table. Earlier, I had explained very nicely how to find DNF and CNF using truth table. So in this lecture, the learner will be able to understand how to find DNF and CNF without using truth table. Very, very important topic in every year, that is on sum will come. So I have taken here two sums, DNF, find the DNF. These two sums I have taken from university question paper. So firstly, I am solving this sum. How to find DNF of this? Negation, P, implication, Q, conjunction, R. Okay. So solution. So negation, P, implication, Q, conjunction, R, this. Okay. So now solving. Okay. Now what I am doing here? Just follow me. So this is equivalent to that is negation. P, negation is there. So P2, so which formula I am applying here? Since A to B, just follow me. A to B equal to negation A, disjunction B. Okay, disjunction B. So this formula I am applying here. This is the formula I am applying here. P, this is suppose Q, P to Q. So negation P, disjunction, that is Q to R. Try to understand. Okay. I think everybody understood this thing. I'm applying this formula over here. Okay. Now what I am doing, that is applying De Morgan's law. I'm applying here De Morgan's law. What is De Morgan's law? You know De Morgan's law, that is negation of this. What is De Morgan's law? De Morgan's law since negation of A conjunction, A disjunction say, A disjunction B is equal to negation A conjunction negation B. Okay. So this formula, this is De Morgan's law. De Morgan's law. I am applying this. Okay. So now that is negation of negation P conjunction, that is negation of Q to R. Okay. So this is the that is De Morgan's law applying over here. So here is disjunction, it will be conjunction. And negation of negation P, that is, this is also P. P to negation, again disjunction, again De Morgan's law applying here, that is negation Q, this is conjunction, this will be disjunction, negation R. Okay. So this is again here I am applying, just follow me. Again here I am applying De Morgan's law. Okay. So now P to this. So I am applying here P to this. I am applying here, that is I am applying here which formula? Tell me. Distributive law. That is P conjunction negation Q, that is disjunction P conjunction negation R. So this is the form. That is what I am doing here by distributive law. Distributive law. You know distributive law. How to find distributive law? That is this to this with conjunction, and here is disjunction, these two, this with conjunction here, okay, by distributive law. This is the DNF, this is the required DNF, this is the required DNF of the given problem, okay, this is the required DNF. Note that for DNF, you should remember always within bracket it should be conjunction, outside bracket it should be disjunction. Be careful. All you see, this is conjunction, outside is outside the bracket, that is within bracket you can say it should be disjunction, and within bracket it should be conjunction. Okay, so this is the DNF. Now this sum. So how to solve this sum? So just writing the sum first. Solution, that is solution, that is I'm just copy this sum P negation Q implication P, and another thing I am telling, this is actually what? This is actually double implication. This is implication, this is double implication. So in every cases, that is without using truth table or without using truth table or with using truth table, in all cases you will see in DNF and CNF there will be no there will be no implication and double implication sign in the required DNF. Okay, be careful. If you are getting the required DNF in that is in implication or double implication, that means your sum is wrong, you will think. That is in the required, what I mean to say, in the required DNF or CNF, it should not be implication and double implication. That is, if in the given expression, if in the given problem is there any implication or double implication, then you have to remove it. How to remove it? I already told you. For implication, then you have to apply this formula, and for double implication, you have to apply this formula for double implication. For this double implication, that is suppose A to B double implication, you have to apply this formula. Okay, A to B, then conjunction B to A. You have to apply this formula. Again, you have to apply. This is implication. This is implication. Okay. Again, you have to apply this in this formula. That is implication formula. Okay. So firstly, one by one, I am doing. Just I am removing this part. Okay. So now you see. So what I am doing here? I am doing this is negation P, conjunction negation Q, to now apply P to Q. So P to Q. So what I am doing? P to Q. Sorry. P to Q. So tell me. So the question is, it will be negation. It will be negation. So this is the negation. This is negation. Okay. This is negation actually. What I am writing clearly. This is negation. Okay. P2. Okay. Negation Q. Okay. So that means what will you do? This part I am applying. So negation P to applying this formula. Here I am applying, this is double implication. We are removing double implication into this formula. That is P2, negation P2, that is double implication formula. P2, what is formula? P A to B, then A to B, then conjunction B to A, that is implication. That is P2 negation Q, then conjunction minus, here is minus Q to P. Okay. So this formula that is applying here. Okay. So here will be on bracket will be there because this whole thing with this thing is applying. Okay. Now negation P, negation Q. Now tell me. Now applying which formula? A to B. A to B. Implication for negation, then disjunction B. Okay. So negation P, then disjunction, negation P, then disjunction, negation Q. Then negation of negation P, Q, then disjunction P and another bracket. Okay. This will be this. Okay. Okay. So now what will you do? What will you do? That is negation of negation Q, that is this thing, this equivalent, negation P, disjunction negation Q. Try to understand this. This is negation P, negation Q, negation of negation Q, that is Q. This formula you have to remember. This. Okay. This we are getting. This we are getting. This we are getting. Okay. This we are getting. Okay. Now again we are applying here which formula? That is A integration B. Negation of A, disjunction B. That is this with this with this. Which formula you have to apply? You have to remove, that is implication. This implication you have to remove. Okay, I'm just removing this part. Okay. Now, okay. So now what I'm doing, this, that is negation, implication removing. This formula A to B, negation A, disjunction B. So negation of negation P, negation Q, negation of this, then disjunction of this part. That is negation P, negation Q, disjunction P. Okay. Is it clear now? Just applying A to B, that is A to B implication formula, negation A, disjunction B. So the negation of this, disjunction of this. Okay. So now which formula applying here? That is, you can write, since A to B, that is equal to negation A, disjunction B. This formula applying here. Okay. Okay. Now here I'm applying here De Morgan's law here. So De Morgan's law, what is De Morgan's law? You know, just we have done negation of this. So that is negation of negation P, negation of this is disjunction, so it should be conjunction, negation of negation Q. Okay, this applying here De Morgan's law, and this will be as it is. I'm keeping this as it is. That is negation P, disjunction negation Q, this Q P. Okay, as it is. Okay. Now what will I do? What will you do? Negation of negation P, that is P. Negation of negation Q, that is Q. P to Q. This will be as it is. That is negation P, disjunction negation Q, conjunction as it is. Q. This is P. Okay. Now what I am doing? I am applying. That is, I am applying here. That is the property of distributive law. Distributive law I am applying here. Just follow me. Distributive law. So what is the distributive law? This with this and this with this. This with this. Suppose this is A, this is B, this is C. So A, disjunction B, conjunction C. So be careful. A, this is A, this is B, this is C, suppose. Thus, you are thinking this as A, this as B, this as C. So A disjunction B, conjunction C formula. So that is called distributive law. So distributive law applying here. P conjunction Q, this disjunction this, negation P disjunction negation P, this with this disjunction Q, negation P conjunction Q, then P with P, negation P, disjunction P. Just I am writing, then you will understand. This is conjunction, negation Q, this is negation Q. And last one, that is negation Q, conjunction P. This. Okay. Which formula? This is actually the distributive law. This distributive law here. Distributive law. This and this. Okay. This with this. Actually, I am not applying distributive law over this. This one as it is. This one keep as it is. Now we are applying distributive law over here. This with this. Okay. This with this, negation P to Q. Negation P to Q. This is conjunction. And here is disjunction. Negation P to P. Then again disjunction. This disjunction. Negation Q to Q. Then disjunction. Negation Q to P. Okay. I am applying actually disjunction, that is distributive law in here actually. In here. Suppose this is A. Okay. This is, that is, okay. So now, this is, you can say, extended distributive law. This is also called extended distributive law. Now, negation P, conjunction P, this is false. Negation P, try to understand. This one I am just removing. So this is equal to P, conjunction Q, disjunction, negation P, conjunction Q, this part. And this one, that is this is actually false. This is actually negation P, conjunction P, this is false. Similarly, negation Q, conjunction, this is also false, and this is negation P, Q, conjunction P. So try to understand what is this, what I am applying here. Since negation P, this is P equal to false, and negation Q equal to false. Again, what I am doing here, so this is false. So which formula? Suppose S disjunction false equal to S. This formula again since S disjunction false equal to S, so this is false, this is disjunction, so whole thing into false, so this will becomes, this is okay. So this formula I am applying over here. So we can write P conjunction Q, disjunction negation P, conjunction Q, and disjunction. And here I am applying which formula? Commutative property. Negation Q. Next line I am writing, that is negation Q, conjunction P. Okay, negation Q, conjunction P. Now we can apply commutative property. So P conjunction negation Q we can write. That is P conjunction Q. Try to understand. Then for disjunction negation P conjunction Q. Then this commutative property. So P conjunction negation Q. So this is the required DNF. This is the required DNF. This is the required DNF. So you see, in the this is the required DNF. This is the equivalent formula of this. This is the equivalent formula of this. So you will see. So in what I told in the earlier, I told that you have to remove implication and double implication from the given problem. This is the given problem. So implication and double implication already removed in this formula. So this is the required DNF. And one thing I told you that within bracket it will be conjunction, outside the bracket it will be disjunction. You see within bracket all you see in these three this is within the bracket, this is conjunction, and outside there is a disjunction, these two. Okay. So I think everybody understood very nicely in this lecture, that is how to find DNF without using truth table. In the next video, I'll come with my new video, that is find the CNF without using truth table. Okay. Till then, bye bye. Thank you very much. Thank you.